In this problem, again, we're trying to figure out between substitution and elimination, the exact mechanism, and the products of the reaction. Here we have a secondary bromide, and secondary can undergo any of the mechanisms. SN1, SN2, E1, E2. So that doesn't help us narrow things down much. Next, we have this sulfur nucleophile. If we break this apart, Na+, SH-, we get this nucleophile, but one thing to keep in mind with sulfur nucleophiles, whether they're negatively charged or neutral, is that they're strong nucleophiles, but poor bases or weak bases. So what that means is this is really only going to do an SN2 reaction. So that really helps us narrow down our mechanism. The last thing we'll consider here, we are given a solvent, DMSO, that's polar aprotic. And that's going to favor E2 and SN2 reactions. So with this information, this narrows down our mechanism where we get a match that we can undergo an SN2 type reaction. If that's the case, since we have this chiral center here, the SN2, we're going to use SH- as our nucleophile. That comes in from the backside of our bromide leaving group. So that attacks, comes in from the back. We lose our leaving group. And this SH group will now be pointed to the back since the bromine was pointed out. And then our byproduct would just be the bromide ion. So this SN2 product would be the major product of this reaction.